Okay, um, should be going now. I know it's been a little bit since I've done one of these, but we're back. So let's just look at this problem. First couple pages are pretty easy. We shouldn't really have any difficulty with it. Um, no, I'm just gonna leave it at that. Okay, and 706 divided by that, 0.0593. Bang. See, that's as easy as it is. So 11900. Okay, well, you know, as long as it looks roughly like the answer should look. Okay, what is the remainder of that? Now this is how I personally solve it. I just divide first, right? And that's how many times it goes in as a whole number, right? So then I just subtract that away. Now I have the how much is left, and you multiply that by whatever you're dividing by. That's probably the fastest way. I don't know if you guys knew that. I had to kind of learn that out myself, honestly. But I mean, it's not too difficult. 3.62. Okay. He walks around these many laps. Uh, this that's this long. I mean, since it's asking in yards and it gives us how long each track is. Oh, sorry, how long each lap of the track is. All you do is multiply. So 6 times 440. Again, these are really basic problems. Okay. Just wanted to make sure my mic was going. Rectangle. So we have 1.16a and a. And they multiply together they multiply together to get 5.28. Well, I'm just going to start off by setting that equal to 1.16a squared, right? Since the length of this side is a, the length of this other side is 1.16a. So then I'll divide each side by 1.16, and then those would cancel out. So divide 1.16, and then to get rid of that square, you just take the square root of both sides. So the square root of 5.28. You could have also used the numeric solver, but honestly, if you saw that as fast as, on the test, I would have probably solved that in a few seconds. I mean, if you could do it like that, then that's probably the best way to do it. So 2.13. Okay, now going on to number 10. So we're asked for the perimeter. Well, from what I can tell, we're having to solve this since it doesn't give us what it is, but we can make a right triangle pretty easily. Uh, this is the height of it with 10.7, and this little bit is 26 minus 10.4. And then of course we're going to use the Pythagorean theorem. So 10.7 squared, this side, and then we're adding 26 minus 10.4, again, which is this little bit right here, squared. All right, 18.9. Oh no, yeah, 18.9 up here, 0.92. Around a little bit. It's a little bit messy, but there's the eraser. Okay. Oh, you see now it just like took out half of it. All right, well, y'all know what I'm trying to do anyways. So 18.92. Okay. Up. And again, we just add that to all the other sides that are already here. So 26 plus 10.7 plus 10.4. All right. And we get 66.0, which is the correct answer. That kind of looks terrible. 66.0. Okay. Well, that's the first page. Again, pretty light. Should only take you like under a minute. Again, I'm going through it kind of slowly because I want to make sure y'all understand it. So this next one, it looks like we're going to have to use a ratio. Okay, there we go. That's good enough. Markup. So text, which is 0.5 and half of an inch tall, is easily legible from that many feet away. So you can tell the ratio right now is 1 to 12, right? Because it's 0.5 over 6 feet. Oh, sorry, it's not 1/12. It's 144. Because if you convert if you convert 6 feet to inches, you'd have 72, and you have to multiply 72 by 2, so it's 144. So if we're point 0.1 of a mile away, the uh, the size of the text should be a 144th of it. So all you have to do is point 0.1 divided by 144. That's how big it should be in miles. Of course, we're asked in inches, so then we just convert it to feet, and then 2 inches. And we're getting 44, which is the correct answer. Again, you could have set up the whole equation like 0.5. Oh, that kind of looks bad. 0.5 over 6 is equal to like x over whatever. But I mean, either way will get you there as long as you find the ratio. All right, moving on. Number 17. So they celebrated their 50th wedding anniversary. How long have they been married? So they've been married for 50 years. So 50. You could also use the apps, side tools, but I'm just gonna do it as normal. Oh, let me get back out. 50, right, times 365.256 is how many days, and that's multiplied by 24 is how many hours, and then multiply it by 3600 to get how many seconds. And honestly, I probably should have been scientific notation because I'm not counting all those place values. 1.58 times 10 to the ninth. Okay, so Ted invested that much money but lost money. So if the percent decrease was that much, how much did he lose? Well, if he lost that much, I think you could just multiply it. And oh, now you said that you gotta convert it. You have to put it back in normal. Okay, so let me run that back. 100 and 158.75. Yep, that's right. Because it asks us how much he lost. It's not asking us how much he has left. All right. Perimeter. Well, there's other ways you could do it, like using the triangle program. I'm just going to use the Pythagorean theorem because it's fast. You all know it. This time we're given the hypotenuse, so we're just going to have to do that squared minus that leg squared. And that will get us this leg, and we just add it to the other two. Basically, it's the same thing as we did with the other perimeter one. Probably a little bit faster though. All right, 197, which is correct. Now we have another problem. As for the area. Now for this sort of problem, since we'd have to figure out this, and then calculate the area, that's a lot of steps. On a pretty much one step problem like this, I would just use the regular calculator. But if it's gonna take multiple steps, I just use the triangle program. It's pretty quick anyways. Angle, side. It's number 4. 90, 32.5, and 710. Okay, and then you just keep on going down. This calculator is a little bit iffy. And then it's 1.11 times 10 to the 7th. Just like that. Okay. You could click on to easily exit the program. Now we're already on page 3. Okay. We're rushing through. Now, problem 26. Markup. Okay. So he walked off a square 1 acre field. So the side measurement, she estimated the side measurement to be that. So what I would do is just figure out how many feet squared an acre is, right? So instantly side tools, bang. So unit converter, and we're converting area. And it is a 1 acre field, and we're just figuring out how many feet that is. And then since it's a square field, once we get it, you see it takes me a second to exit. All I have to do is take the square root of it, and that'll get us the side, right? And we're asked for the percent error, right? And in case you don't know the formula, there's a percent program that if you run it, I have a ton of programs on here. I don't have this amount of programs on my actual calculator. If you run it, it gives you the formula. So you see percent error, B is the exact, so you put the exact on the bottom. And you put the estimated on the top. And the estimated is 195, so you divide it by 208. And then you subtract 1. Just like that. Negative 6.57. Negative, oh, wrong spot. Okay, now how do I was meaning to erase this a little bit. So we're looking at problem 27. It gives us the mass of moon's Earth, right? Oh, or sorry, Earth's moon, which is this many kilograms, right? We're also given the mass of a meteorite that crashes into the moon. And it's asking us for the percent change in moon mass. So normally, I better get this out of here. You worry about the percent of, like, you use a formula for it, right? But in this case, it won't work because the if you convert this to kilograms or this to pounds, it'll be such a huge difference that the formula will just come out like there's a 0% change. So what you're gonna have to do is put this meteorite in terms, like, put the mass of the meteorite in terms of the Earth, of the moon's mass, right? If you find that fraction and multiply it by 100, that'll find the percent change, right? So that's what we're gonna do here. So again, I'm just gonna start by converting. I'm gonna convert from pounds to kilograms just because I don't want to have to worry about all this. You know, that's a lot. So pounds, we have 11,000, and we're converting to kilograms. We just export, and yeah, all we have to do, you see, this is how it weighs in kilograms, right? And if you divide it by, in parentheses, 7.34767,309 times 10 to the 22nd, this will tell you the percent mass, like the fraction of mass, the meteorite is of the moon, right? This is how much it's kind of increasing by. So you just multiply by 100, and you get your answer. See, during the test, I remember this actually. It was a test last year. During the test, none of us got it. I put 0 because I used the regular formula, but for this problem, you didn't have to do that. And if you did, again, if you tried to do it, you'd come up with 0. So, kind of interesting. It required you to think differently, you know, not just like the same pattern again and again and again. Uh, Now, the product of two consecutive positive integers is this. What is their sum? I'm sure most of y'all know the trick by now. If we're given the product of two consecutive integers, we just take the square root of it, and it'll give us the value right in between them. Roughly, right in between, you know. Like, there's some extra decimals, but you see it's 0.499. You round that to 0.5. You have 638 and 639. Sorry, my mic cut out there. You have 638 and 639. So you add them together, you get 1277. All right. And then we also have this problem, since it's volume, I wouldn't even worry about using the geomfig program. This is really easy. You just divide it just like this. You divide by since the volume, the volume is all of these multiplied together. Let's say this is x. We have 30.2 times x times 46.3 is equal to this. You just use algebra and you just divide by these, and you have x by itself. I didn't want to draw it out because it will take me way too long. I still want to enjoy my last day of this weekend, so 72.2. That's 7's kind of long, but I mean, we're almost done with the page, so I'm not going to worry about it. And then lastly, this is one I would use the program for just because it's fast. You know, geomfig, it's the square pyramid, side length, height, 0.294 and 0.344. And just like that, you have your answer. Total surface area, 0.306. There we go. All right, moving on. Next page. All right. here we are. Let me drop this down. Oh, now this was a page that I saw with Calvin. Uh, we solved 38, and I'm gonna explain to you how we did it, but that's a fun problem. 37, I'm gonna skip that because that will take way too long to explain. I'm hoping to make a program for it one day, but that I haven't had the opportunity to yet, and I'm still understanding like if it could work for every single problem like this. But basically, what it's saying is, I'm just gonna draw a diagram for y'all. Again, I'm not gonna completely solve it. You have this circle, right, which has a radius. Sorry, yeah, a radius of the square root of 30, which is 5.77. So let's say it's gonna look something like that, right? I'm not good at drawing, so I apologize for that. But you have like 5.77. The first one was better. All right, you know what? This is my last guess. This is my last try. You have 5.77 radius, right? Imagine if it was a perfect circle. And you have a point that's like up here, 2 comma 10, that's on a slope that's positive, right? You have to figure out what the slope is. You have to do a lot of stuff like calculating the distance between the point and the center. So you calculate that angle. You found the negative, there's a lot of steps with it. So again, don't worry about it on a test. Just skip it. Uh, and hopefully I'll make a program for it one day. But yeah, don't worry about it. 36 though. I'm getting sidetracked. So, in a room full of people, 40% are men. Okay, 1/3 are women. I'm sorry, 1/3 of the women are blonde. And of the blonde women, 1/3 have military experience. If 9 blonde women have military experience, how many people are in the room? So, you could use numeric solver. I'll show that I guess in a second. I'm just gonna start out for how I would do it, right? You have 9. The chance of it is 1/3. So you would have to multiply it by 3, right? Because that's how many. We're basically figuring out how many blonde women there are, right? So this is roughly how many blonde women there are. And now we're gonna multiply by 3 again. This is how many women there are, okay? And since 40% are men, 60% are women. So uh, what's the what's the fastest way to multiply that? Uh, multiply it by. I'm just gonna figure out point 6 divided by point 4. 1.5. Okay, I probably should have done that in my head. 1.5. Okay, so it looks like. Oh yeah, I better flip the page on here and rotate it. There we go. Okay, Sorry, what was I doing? Let me just restart. So 40% are men, so that means 60% are women. So yeah, you would just divide it by 0.6. I don't know what I was doing. Okay, never mind. 9 times 3, right? That's how many blonde women. That's just how many women, and then divide it by 0.6, right? 135. Yep. Because in a sense, whenever I'm multiplying by 1/3, I'm dividing by. Yeah, whenever I'm multiplying by 3, I'm dividing by 1/3, right? That's the same thing as multiplying by 3. So uh, that's why I multiply it. But then once you get to 0.6, I mean, it's kind of difficult to handle that. So that's why you just divide by 0.6. So yep, 135. Again, 37, we're skipping that. That might be like one of the 2 or 3 problems we skip during this video. Okay, 38 is a really fun problem. So let's let me show you the diagram that Calvin and I drew, and then Lyscout kind of helped with me with solving it. So we're gonna call this velocity. So we're making a graph, right? This down here is time, right? In seconds. And we have velocity be our y-axis. I better, and I'm gonna put feet per second. Okay, I better focus on the problem first because y'all don't even know what it's about probably. Okay, so it tells us that the max speed of a Japanese high-speed train, right? So this right here, this velocity has to be 190 miles per hour, right? And they require 5 minutes to speed up or slow down. So That's what these ending parts are, right? That's the acceleration and deceleration. Both of them take 5 minutes. So you know that for the first 300 seconds, it's going to be speeding up. And for the last 300 seconds of the trip, it's going to be slowing down, right? But then you don't know about the middle section, but we'll figure that out. All right. And then it asks us how long it would take to go from here to there, right? Well, I don't know honestly where, of course Tokyo, I know where that is, but I don't know where Osaka is. Uh, I'm assuming just somewhere in Japan. A distance of 493 kilometers. Okay, well, I would first convert kilometers to miles, right? Since it gives us the speed in miles per hour. So apps, side tools, it's about zero point 0.6, right? 0.601. I don't remember really. I honestly want to try if I got that right. 0.601. That's my guess. Come on, let's see. Zero point 0.6. Oh no, it's 0.621. Okay, so I just forgot the two there. Well, I'm gonna export that because once I get here, I could just multiply by how many kilometers there are. And now that's how many miles we're dealing with. Okay, 306.335, so on and so forth. Okay, so that's how long of a trip they have to go on. So I would figure out how far they've gone during this time, like how much distance they've gone, right? Because if we can figure that out, we know how much distance they have to go in here. Okay, so the reason why I'm using velocity as the y-axis and not speed, I'm sorry, not the speed, I meant yeah, velocity instead of distance traveled, is because if we find the area under the curve of this, right? If we find that area, that's how much distance they've traveled, right? Imagine a velocity of a graph. Let's say you're going 1 feet per second, right? Just a solid, imagine it's like the same graph, right? And this is like y equals 1 or something, okay? And if you're going 1 feet per second, you're going to be traveling, if you're on the area under this, it's going to be a foot every second, right? Obviously. That same rules applies for this problem over here. So we have to figure out the area under this curve. And how we do that is by finding the slope. Well, it tells us how long it takes to accelerate, and we're assuming it's starting at 0, right? If it's just completely, it's not moving at all. And eventually it ends up going 190 miles per hour. So again, I'm gonna put in feet per second. So 190 divided by 360. That's how many miles per second, and now that's how many feet per second. Okay, so 279 roughly. We'll keep that on our calculator. So that's how fast it's going right here. Okay, and if it's going that fast after 300 seconds, that's the acceleration per second. Okay, so it's going to be we can treat it as if it's a linear line, right? So math 9. So from 0 to 300, and the slope is 0.928888. That should be good right there. X, and then d of x. That gives us the area under the curve, right? But we don't just have one of these. We don't just have the acceleration. We have the deceleration, which is the exact same, right? So we just multiply it by 2. And that's how many feet. Let's divide it by 5,280. That's how many miles. Well, what was it? 300. I think it was up here somewhere. Yep. No, that one right there. Okay. That's how many miles they have to travel minus the speed up and speed down or deceleration speed distance, right? That's how far, sorry, they have to travel in this area, okay? So all we have to do then is just divide it by 190. That's how many hours they need to be they need to be traveling at max speed, okay? So that's 1.5289, whatever, okay? Well, that's not our answer because we still have 300 seconds on both the beginning and the end. So we just add what a tenth, sorry, 10 out of 60, since there's 10 minutes total out of 60 minutes in an hour. So it's just 1/6, 1.7, just like that. That's kind of going on a rant there, but you see the reasoning now. That was fun. Okay, now we have use of the triangle program. Pretty handy. 0.631, 0.592, 0.578. Okay, big R is coming up. There it is, 0.347. Just like that. All right. We also have uh, an isosceles and scalene triangle problem. Well, we know that this is the isosceles, and then we could figure out the angles, and if we figure out what this angle is, then we could do angle, that we could do angle, angle, side. So that's probably what I'll do here. So side, 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 1.5, sorry, 1.58, 1.58, 2.77. Okay, now we have the angle. So it's stored under D. So I'm going to exit it, go right back in. It's stored under D. We have, again, angle, angle, side. So number 4, zero point 0.7 times 180. We're having to put it in degrees, of course, right? Y'all have done this. And then, again, it's stored under D. And side 1 is 2.77. So since angle 2 corresponds to side 2, that's what we're looking for. Ooh. Now that... Oh, wait. Interesting. Now that, I think, is wrong. So, I'm just gonna go through, maybe? It's saying that they're the same angle. Did I plug something in wrong, I guess? Yeah, because it spit us out. Okay, well, I'm just gonna try to run that back then, I guess. Did I miss something? Angle, angle, side, yeah. I don't see it quite yet. Okay. Well, I'm gonna run it back, I guess. 1.58, 1.58, 2.77. So 28.6, maybe it's erasing the variable, I don't know. So well, the angle we have is 28.767. 28.767, just remember that. 28.767. Okay. 28.767. I don't know why it gave me the wrong variable. I'm kind of confused by that. Okay. There it is. Yeah, that's kind of weird. I guess maybe I plugged in the wrong thing. Okay, 2.07. Just like that, we have our answer. Okay, so skipped one problem so far. This should be a pretty fast page. All right. So looking at, okay, my mic keeps on shutting off. Looking at problem 46. It's a volume since we're dealing with pillows, right? We're gonna treat it as like a sphere. Even though it's probably more of like a cylinder. I mean, I don't really know the best way to describe the shape of a pillow. Uh, so 12-inch pillow requires that many watts of stuffing. I'm gonna put the number of inches on the top and the number of wads on the bottom, and it's gonna stay consistent on this side. Now we have a 30-inch pillow, so we're having to cube it, and then we're just gonna put X for the number of wads. Oh, I forgot. Yeah, so for problems like this, you never really want to put X to be 0 because this will throw an error. It won't find it because obviously anything over 0 is undefined, so you just have to change it to a different variable. 172. That's a pretty big number, but I mean, it's reasonable, so. Oh, 172. Okay. So the growth of a beagle dog, well, whenever I look at problem 47 and I see these, I instantly plug it in. I don't know if it's linear yet. I don't know if it's quadratic, but I start plugging it in. And for this one, it is not linear actually. So you have to do something else. So we're given the height of it, right? Which is only that's only one of the three dimensions to get into like of course 3D. Whereas weight is already in three dimensionals. So how to solve this to make it linear would either be by cubing the height, right, to make it three-dimensional, or by taking the cube root of the weight to put it into one-dimensional. And I prefer just cubing the height. So 9 cubed, then 9.7 cubed, 10.3 cubed, 10.9 cubed, and 11.3 cubed. Oh, there's one more actually. 11.3 cubed. And then lastly, we have 12 cubed. So those are some big numbers. Okay. And then we also have 9.5 pounds, 11.25 pounds, 13 pounds, 15 pounds, 16 pounds, and 18.5 pounds. Okay. Now it's a linear line. So just stat calc 8, y1. Now we can just plug in 14 cubed for the height, and it'll give us the weight. 27.8, which is correct. Okay, now what is x is equal to x to the fifth power is equal to 3x squared plus 1. All right. That's probably yeah, that's way larger than it needed to be. 1.51. All right. This is pretty easy. Now, going on to 49, total volume, we're given a half cylinder and rectangular solid. So we don't know what the radius is, but we know that the side length is 2r, right? Since it's right on the top. So I'm just going to start up setting the equation like this. 660 times x times 2 times 1510 plus that's the whole volume of this rectangular solid, right? Plus, and then just x squared times pi times the height divided by 2. Just like that. And then we just set it equal to the total volume. 2.1 times 10 to the ninth. There we are. 610. Okay. Now for this next one, it's a hemisphere with a conical cavity. First thing I will do is just figure out the hemisphere. So this right here is a cavity, so it's not going to be 3 pi r squared like a hemisphere normally is. It's going to be 2 pi r squared. Okay, and we're adding the conical cavity. Well, if you can tell, I don't know if y'all heard that. There's just some noise in the background. Okay, but as I was saying, so both the height and the base of this triangle make a 90-degree angle, and as you can tell, it's going to be a 45-degree angle, right? So it's a 45-degree right triangle. So the L is going to be just r squared of 2. And for the lateral surface area of a cone, which is what we're having to solve for here, it's pi r L. So I'm just going to put pi r squared times the square root of 2. And that should get us our answer. So, for number 50, oh wait, oh no, it's because that's still a huge number, 0.475. Okay, so you gotta make sure you change everything. That's gonna be a lot smaller. Okay, well again, sometimes it spits out negative. That's only because x squared is the only time you see it, so it can be technically negative, but for this specific problem, you're only looking at the positive. Okay. Well, 2 more pages. We're going pretty well. Um, let's see. Let's see. All right, let's go down. 57. I might try that. I don't know. That is kind of similar to the problem we solved earlier with the speed up and I don't know. We'll see. We'll see. Okay. Solve for a if the area under the curve equals 6. So for this problem, whenever you're solving for the area under a curve, if something's out front or on top, you can move it out. And what I mean by that is you could just move it outside of the area. So let's say you have like 0 to 8 and you have like 9x, right? Well, that's the same thing as doing 9 out front, 0 to 8, x on the inside times x, right? If you think about it, it makes sense. But uh, so that's what we're going to use here, right? We're going to move that a out front and then figure out what a has to be for this to equal 6. So first of all, we have to make sure we're in radians, which we're not, so it's a good catch. Math 9, we're going from 0 to pi, and it is sine of x. Again, we're not worrying about that a yet. So we're just figuring out what this area is. The area is 2. So for the area to equal 6, we'll just do 6 divided by 2, which is 3. So a has to equal 3. Pretty light. Okay, 57, I'm going to try to do that at the very end. Uh, so we'll see. 59, okay. Well, this likely would be a pretty difficult problem if we didn't have the program for it. That could do it all for us. So again, y1, y2, you just plug them in there. Then you go to, I don't know why I went to line ends. You should just go to E, if you have a math calculator that is. Go up one, DWS, right there. Is it a vertical or horizontal line? Well, since it's y equals, it's going to be a horizontal line. Y equals 0. And solving for volume, left boundary 0, right boundary 11.11, I guess. And guess, well, it only intercepts one time, so you could have the guess pretty much be whatever you want. Lower is, like the lower it is, the safer, I would say, though. Okay, volume is 13.4, which is correct. Alright. Now, I don't know why I skipped 58. I just missed it, I guess, but it's a really easy problem. So let's knock that out really quickly. Negative 8, 16, 27, negative 22. And we're adding 5n, which is 13, negative 8, yep, 26, and 14. So what we're asking for row 1, column 1, 41, 41.0. Now, 3 identical circles and a small tangent circle. So we have something like this. Oh, if you connect all of them, since they're all identical, see, let me actually zoom in on here because I want to make sure I'm drawing as best as I can. So we have a what could you call it? An equilateral triangle, right? 60 degrees. Well, honestly, let's use this way to do this. So we're asked for the little one on the inside. So how could we do that? We have a radius right there. Let me remember. Let me see what I can remember here. Yeah, that's how you do it. That's how you do it. Okay, so again, this is an equilateral triangle, right? We're gonna split it up. So On the inside of any shape, the angle is always 360, right? But if you divide it up into like say 3 different sections like we did now, you have 120-degree angles, right? So this is 120. And since we divided all the sides by 2, this angle, which was previously 60, is now 30, right? So we have 120, 30, 30. Okay? Well, yeah, and this it took me a second to see, but yeah, it's not too bad. On a test, I probably wouldn't even be able to see it, honestly. Okay, so we have side one, uh, which is just double the radius, right? And then we also have 2 angles, so we'll just do that. Angle, side angle. So again, normally it was 60, but we divided by 2, so it's now 30. Side 3 is 776 times 2, and then 30 again. Okay, and then whatever the other 2 sides it gives us, right, is r plus little r. So I'm going to exit out. We have a minus, we're going to subtract the big R. That gives us the little r right there. But it's not asking us for little r now, is it? It's asking us for little d, little diameter, which is you multiply by 2, 240. Not too bad. I was kind of worried I wasn't going to be able to see it there. Okay, moving on. 61. Ooh, that's a whole bunch of words. I'm kind of scared. Ooh, you never want to see that on a back page. All right. So cross-sectional area, the tensile stuttering. The tensile failure load of a rod is proportional to the rod's cross-sectional area. Cross-sectional area. So is it just like the surface area? Like I'm just gonna treat it. I don't know. Oh, yeah, I'm not trying to do that. The surface is lost at that. How long? Oh, I might be able to do it. So yeah, I'm gonna try it. I'm gonna try to see if I understand what it's saying. So I'm just gonna guess that it's talking about like this cross-sectional area is talking about the just area of it, right? So we have a sort of K value, right? That's normally what it's referred to as. So we're gonna have, and it's proportional. So if it's proportional, that means that it's going to be on opposite sides, right? If it's inverse, like A times B equals C, A and B are inverse. So basically, for A to increase, B must decrease. In this case, since they're proportional, one goes up, the other must go up. So it's like y equals x. So we're gonna have them on opposite sides. So we have to have 0.25 squared, right? Because we're making it cross surface area times pi. I don't think we have to worry about that, honestly, since it's going to be on both sides. So I think all it's really important is just to square it up. So we have 0.25 squared, and we're just going to multiply it by x. I'm going to call it k though, right? I've been always using x. I mean, that's normally what I do, but I'm going to call it k. Must equal 1,400 pounds. So this will give us the value, right, of k, which is that. It's a huge value, right? Now, that's when you multiply the uh, the the diameter. Oh, shoot. Yeah, that's diameter. Okay, well, we'll just again, we could just treat it like it's the radius. If we treat the other one like the radius as well, no, we can't. The surface is left. Ooh, okay, yeah, I'm gonna have to redo that. Let me go back in here. 125. Okay, new value. That's now, yeah, it's gonna be 4 times that. Okay, now we have the actual K value. Now we're given, it is loaded to 650 pounds and placed in a corrosive environment. So it's dropped, right? And the surface is lost at that many inches per hour. Is that the diameter? Because it would normally say inches squared. Okay, I'm just going to treat it like it's the diameter, I guess. So we're asked for like, eventually, what is the maximum? Okay, let's figure this out. Yeah. So this K value, we're going to multiply it by an X diameter, right? And to get, sorry, an X radius times radius squared. Let me just write this out. We're gonna have K, which we already solved for, right? times r squared times, I'm not going to times pi yet because we don't have to worry about that, is equal to 650. What is the lowest amount that r can be? What's the lowest amount that it can be to equal 650, right? Because in a sense, we could also just be talking like that, right? I think. No, it would be that. It would be that. Okay, but it doesn't matter. So again, it's going to be 89600. 89600, which is the one we solve for, times r squared is equal to 650. Now it gives us what r is. Yep, you just have to subtract that. Okay, so this is what r is. And I'm assuming that's talking about the diameter, right? But that's what I'm treating it as. If it's not, then I'm just gonna get the wrong answer. Okay, so how long does it take if it's dissolving it this fast, right? Does it take from for a diameter to go from here to a radius of that? Well, I start off by well, if the surface, I'm gonna just double that r to get that diameter. So if we have 0.25 minus like 0.002x is equal to that. So 0.1073, 0.1703 is equal to 0.25 minus 0.002x. Now I think this is it. I might be wrong. I don't know for sure. I got 40, roughly 40, which is exactly double what they got. So I'm guessing they are talking about just overall like one side, because if you multiply that by 4, yeah, I think they were just talking about a different sense. So the surface, so the diameter is being shortened by 4.04 an hour. The radius is being shortened by, I guess it means like it was being shortened by 0.002 inches per hour on both sides. So a little bit tricky. I didn't get that. But yep, just one quick fix. All right. So this is a perfect example of the exponent program. Exponent number 2, base is 378,856 to the power of 14. Hopefully that can handle it. Yep, it does. 151 and 7.84 times 10 to the 11792. I'm gonna try to make it look really pretty. Okay. A smoke bomb has a fuse that burns that fast. Hank lights the fuse and immediately throws it with the least velocity of that. How long should the fuse be if the smoke bomb activates 2 seconds after hitting the ground? Okay. Well, we could just figure out how long it's going to be in the air for, right? By using trajecto. These are always trajecto problems. It's a little bit more than that, but it's mostly just trajectory. So Earth, and again, it gives us release velocity. I hope that's the last time my mic shuts off. It gives us release velocity and it gives us the release angle, right? And I'm assuming the starting height is just 0. So we have max height. Oh no, we have velocity, angle. Velocity is what, 45? It asks it in feet per second though. It doesn't really say it, but to convert, all you have to do is just multiply by 5,280 and divide it by 3,600. That's how many feet per second it is. And then angle is 65 relative to the ground. Should just be able to plug it in like that. And shall have 0. That's how long it takes, 3.718. So that's time. I'm assuming it's stored under t. Yep. So it doesn't say, but I was just going off on a whim. Uh, and if it has to activate 2 seconds after hitting the ground, you just add 2 seconds. That's how long it should be on fuse for, since he immediately throws it, which is kind of unreasonable, but just to make for the sake of simplicity. So we divide that by 0.7. 2.7 inches per second. And oh wait, no, never mind. We should multiply by 0.7, yeah. Uh, okay. Okay, yep. 4 inches. Oh, just like that. Okay. Regular pentagon, we're given the area. This, y'all might not have it. Even though it's not as useful for calculator people as it is for math, there's a program called Polycircle, and although it's normally used for like polygons or inscribed of a circle or vice versa, it still is handy for situations like this, right? If you don't want to have to, do the math. So what's on the inside? You could choose whatever for this sort of problem, but this is the menu that you really want to care about, right? If you're solving problems like this, you're given the polygon's area and the number of sides. What, 5? Yep, it's a pentagon. Area is 117, and then it gets you the polygon side length, 8.25. See, that's why it's handy having these programs. You don't even really have to think, just plug it in. Okay, hatched area is equal to the isosceles trapezoidal area divided by 2. So I'm assuming it's just talking about this. It's not talking about a little bit up there. It's just talking about this right here. So half of this is equal to that. And it's equal to 3.39. So if we're going to call this, I'm going to call this x because it's probably the easiest. It also gives us an equilateral triangle, which we could actually use that knowledge to know that that's 60 degrees. No, that's a 30, 60, 90. Look at that. So y'all have all taken geometry by this point, or at least are in it, and y'all probably know that whenever there's a line crossing a straight line, it basically has the same angle on both ends, right? Using that property, and given that it's an equilateral triangle, that's 60 degrees, that must be 30 degrees, and that's 90 degrees. So that makes it a way easier. So now, you see, I don't have to really worry about it much else. So if this is x, this must be x divided by the square root of 3. And these two multiplied together must equal 3.39, not added together, I meant multiplied together. These two multiplied together must equal 3.39 times 2. So, I mean, you could use numeric solver. I haven't really used it much, so I guess I'll give it a shot this time. Divided by the square root of 3. Again, you probably could have done it really, really fast if you wanted to, without using numeric solver. But I just want to give it a shot, 3.42. Oh, let me check. Hmm, I'm getting a little bit different. Oh, because uh, I think that's because the hatched area, is it for just, it's for both, right? Yeah, which would mean that you don't have to multiply by 2. Okay, that's a mistake on my end. You see, sometimes I make mistakes even if I figure out how to solve it really fast. 2.42. Yep. You see, that's why you look at the equation. Make sure you're plugging everything in right, because that little mistake of like, oh, I only got this shaded area, it's actually a rectangle, right? So you didn't have to divide it by 2 at all. So yeah, again, you could have just probably multiplied by the square root of 3 and taken the square root of that, gotten your answer. All right. Well, I was able to figure out the answer for 56. It took a little bit. I'm going to try my best to explain it. So, first of all, I'm just going to use the numeric solver, right? And I'm going to convert miles per hour, 100 miles per hour, to feet per second. So, we'll do that really quickly. And another thing I'm going to do is make this into an equation that we can work with, right? 5 feet per second cubed. Well, you can simplify that to become, let me think. If we put it in terms of like the change in velocity over change in time, you'll get the equation to be 5 times time squared divided by 2. Right? It's kind of I'm still iffy on how you get there, but that's eventually the equation you end up getting, right? And I want to figure out at what point does this acceleration so not acceleration. When does it get to be this value? When does it get to be that speed, right? It's about roughly 7.66, right? And if we plug in 7.66 into this equation to find like under math 9, 7.66, right? And we do again 5x squared divided by 2 times x. That should be how many feet they've gone, and that is. So it's roughly 374 or 375. I think I rounded a little bit up. Let me check. Yeah, I did. 0.659. Let me change that a little bit. Maybe that'll change your answer. Again, if you're off by zero point 0.1, it doesn't really matter. Like if you yeah, you see it does change the answer actually. If you're off by point like one, if you're at a last, I'm sorry, if you're off by last significant digit, which in this scenario is just the 4, if you're off by 1, they won't take off points. And in this scenario, we would have ended up getting 375 if you rounded, but again, we would have been fine. But that's how you get the answer. Again, I'm probably not the best at explaining it. I don't fully understand it myself because I'm not in physics or anything, but the answer is 374. So that's where you end up getting. So overall, we only skipped one problem this test, so good stuff.